let's move to the last presentation from this first session of the afternoon. We finally be with Russell Keylley. Are you with us, Russell? He's joining us from USA, representing Phileo by Lesaffre, a global leader in microbial and yeast-based solutions. Yes, you're with us. Welcome.
Yes, thank you.
Welcome. The floor is yours.
All right, so thank you. So in terms of, you can go to the next slide. As you can tell, I am not Ashoff. She is feeling under the weather, and she sends her apologies for not being able to join today or be there. But I will do my best to be an adequate substitution for her. And it did not change slides. So on the next slide. I can't tell in terms of my screen is not forwarding, so it's okay. I guess go back to the previous slide. I see on this that I will change over. So in terms of, I'm sure as you've heard today, from the gut microbiome, in terms of a healthy environment, we have a well-organized physiological environment set up in terms of both extracting nutrients for the animal, as well as providing a barrier to the external world. In terms of compromised systems, we see a more loosely associated mucosal layer, an increase in pathogenic bacteria, and all of these can lead to I'm going to say a health compromise of the animal. Dr. Suchodolski at Texas A&M, he's done I'm going to say an extensive period of description of the impact of a dysbiotic microbiome environment. Next slide. So in terms of changes in the bacterial populations with dysbiosis, we tend, as you have seen, to have a decrease in bacterial diversity, a loss of normal taxa, and then an overgrowth of potential pathobionts or potential pathogenic bacteria. In terms of microbial function, as again we've talked about previously, the bile acid conversion is often disrupted, and this is usually a disrupted conversion of primary to secondary bile acids, decreased short chain. Oh, can you go back, please? Decreased short chain fatty acid production, and then altered tryptophan catabolism. We tend to see a shift in terms of the chitinine pathway, or increased inflammation, decreased serotonin production, as well as increased or decreased indoles production. Next slide. In terms of the dysbiosis index, as described by Dr. Suchodolski, in terms of that, we tend to see in terms of healthy versus diseased animals, again, more inflammatory in nature, decreased short chain fatty acid productions, decreased bile acid production. And then we also tend to see overgrowth with regard to species like Streptococcus or E. coli. And these both can happen at the mid and lower GI tract. But in general, these are both pro-inflammatory movements. Next slide. We can see here in terms of just the correlation with species diversity with regard to the dysbiosis index. You can see here from published data out of Texas A&M, a decrease with regard to some overall species. And then specifically, we can see in terms of the Faeciobacteria and some of the Fusobacterium, we see positive results in terms of the dysbiosis index. Next slide. Some strategies in terms of managing the gut microbiota modulation. Certainly dietary interventions is one option. This includes restricted fats or use of highly digestible diets, antimicrobials, this most commonly metronidazole, biotics, whether that be prebiotics, probiotics, or postbiotics, or even symbiotics. All of these have been placed on the table as options for dealing with these diseased animals. And then lastly, fecal microbiota transplantation. In terms of that, certainly there's been studies to demonstrate that this is an effective management tool is particularly in the animals that are most severely impacted. Next slide. In terms of today's study, really the objective is to evaluate the effect of yeast probiotic Saccharomyces cerevisiae on the fermented metabolites and gut microbiota composition and function in healthy dogs. And this was utilizing a specific strain of yeast probiotic CNCM 5660, which was specifically developed by Phileo for dry food applications. Next slide. In terms of the study that was going to be presented, it's 16 healthy adult beagle dogs. It was an abrupt diet transition from a moderate to high protein and fiber content. You can see here in the upper right-hand corner, the low protein fiber diet, 20% crude protein, 6% crude fiber. The dogs were managed on that diet through 21 days, and then transitioned abruptly to the high protein, 28% protein, 20% fiber at day 22, and then monitored throughout the rest of the study through day 49 in terms of the impact. It's basically in terms of the key points: digestibility monitored, fecal characterization, immunology, and microbiota. In terms of the dose used, 1 times 10 to the 10th CFUs per day were given throughout the study for the probiotic group. Next slide. In terms of statistical analysis, they basically used the Minitab software. Dog was the experimental unit. They did evaluate using both the Grubbs and Rossner test in terms of outliers, and then one-way ANOVAs were performed with regard to the fecal pH, IgA, ammonia, biogenic amines, short-chain fatty acid, branched-chain amino acid, dysbiosis index, and then the bacterial qPCR results. Normality was checked, and then comparisons within group. You can move on. As was pointed out in the earlier talk, this is from the International Scientific Association for Pre- and Postbiotic. In terms of their consensus panel, they define a probiotic as live microorganisms that, when administered in adequate amounts, confer a health benefit on the host. So again, the key points being it's a live microorganism, adequate amounts, and then as was pointed out in the last talk, the health benefits are rather loosely defined, but in terms of that, it must be demonstrated that the host receives a health benefit. Next slide. In terms of yeast as a probiotic, they are, as was pointed out earlier again, they're naturally resistant to antibiotics. They can help in terms of the detoxification of mycotoxins, resistant to gastrointestinal conditions, producer of metabolites, immunomodulate effects. They typically are much bigger than bacteria. There is a low risk of gene transference to bacteria with regard to the antibiotic resistant genes, and then they tend to be more resistant with regard to osmotic stress due to the rigid cell wall. Next slide. In terms of, I'm going to really focus here on the top section of this in terms of the yeast mode of action. in terms of their metabolic activity, decreases the oxygen availability, and this is really to promote a more anaerobic microbiota environment. The presence of their mannins, from their cell walls, are very effective in terms of binding pathogens and decreasing those populations. Presence of the beta 1,3,1,6 beta glucans really aid in terms of stimulating immune support. And then the presence of nucleotides, peptides, vitamins, and minerals also contribute from an overall nutrition component. In terms of this particular strain, it's selected specifically for its ability to survive the gastrointestinal passage, as well as being very stable with regard to application to a dry material. In terms of the production of this, we specifically challenged this strain to produce large levels of trellulose during the latter stages of the fermentation process, and then we utilize a specific drying process to micropearl, and this really enhances the flowability of this material, as well as adding a protective component to promote shelf life. In terms of the fecal results, you can see in terms of starting on the left with pH, you can see starting at day 23. So this is just a couple of days past the diet transition. We start getting some separation with a probiotic group represented by the orange line, having significantly lower pH with regard to the fecal material. Again, in terms of the ammonia, we can see periods, particularly early on, day 23, we see a reduction in the amount of ammonia produced. And then again, in total, the total biogenic amines, you can see again periodic points where the probiotic has advantages. In terms of the fermentative metabolites, I'm going to just highlight in terms of the butyrate as well as isobutyrate. These are both significant points with regard to the post-diet abruption change. Next slide. In terms of the dysbiosis index, as plotted here, you can see in terms of the starting at day 35 and 49, we get a significant separation with regard to the dysbiosis index. You can see in terms both groups are responding to the diet change, but the probiotic group does a greater decline, a significantly greater decline. Next slide. In terms of the microbiome changes, again, in terms of the Turibacter here and the E. coli, you can see in terms of opposite directions, with the E. coli significantly increasing in the control group. And we can look at that from coming up in a little bit greater detail. Next slide. In terms of bifidobacterium, again, you can see a significant, highly significant increase post-diet change with the yeast group. And then in terms of E. coli, we get a much stable environment, or more stable environment, with regard to the probiotic group, the Lesaffre group, in terms of particularly around day 23 and 29, no difference observed at day 35, but overall lower E. coli levels post-diet change. If we look in terms of just the beta diversity, we look in terms of the A, you can see that in terms of the prior to the abrupt diet change, both groups were very similar with regard to their beta diversity, but then moving in terms of after the diet change, we can see a significant separation between the control groups and the probiotic group in terms of a much more diverse environment for in this later phase. Next, in terms of functional genes with regard to the diversity, again, you can see a much closer overlap with regard to the two groups prior to the dietary change, but then a clear separation following the abrupt diet change, with particularly for the probiotic group. In terms of some of the gene activity that was noted, certainly we saw an increase in the Streptococcus virulence factors in the control group following the diet change. Next. Also an activation in terms of indications of osmotic stress. Next. Higher transportation of the biogenic amines, and then greater methane production with regard to the genetic activity. And then in terms of this study was repeated just to verify that it was consistent, so we can move on and take a look at the second round. So again, in terms of this was experiment 1, following the finish of that, did a complete washout for 3 months, and then basically reassigned the animals to repeat this study in experiment 2. It was an identical setup with regards to the methodologies. Next slide. In terms of just basically taking a look here to ensure that there was no cross-contamination between the groups, you can see in terms of the detection of Saccharomyces cerevisiae, here's the probiotic group 1, here's the probiotic group 2, and you can see in terms of the control groups, there's no presence of Saccharomyces cerevisiae detected, and this is another good indication, non-colonizing, as Diana pointed out early. The yeast are non-colonizing, non-spore forming. So in terms of that, it's a very effective tool with regard to supplementation period. Next slide. So if we take a look in terms of the microbiome, again, we have the experiment 1 here in the lighter orange, the probiotic group 2 here in the sort of reddish material, and then the control groups on the right side, experiment 1, experiment 2. You can see that in terms of both studies, the populations align very well with regard to their separation, and this is really a good indication of just consistent results and repeatability with regard to the use of this yeast as a probiotic. Next slide. Some take-home messages from Ashop is that yeast probiotics are safe, well tolerated by dogs, and they can benefit the gut and overall health of dogs. These effects were observed under stressful conditions, specifically an abrupt diet change. The fecal quality of the dogs receiving the probiotic were improved, decreased putrefactive compounds. This is in terms of related to the changes in the pH, the ammonia, and some of the biogenic amines. And they basically also, these compounds can impair intestinal functionality and worsen fecal odor. We got improvements with regard to the dysbiosis index and modulation of the gut microbiome composition. The response to the probiotic consumption was repeatable, and this was after a 3-month washout period. As you know, in a lot of cases, these results, while promising, we still need to look at these under some larger populations as well as the various life stages. Next slide. Probiotics need to be identified at the strain level, need to be alive as they are defined, and have evidence for their safety and efficacy. Particularly in terms of this, as I mentioned at the start, this strain was specifically developed for use in dry post-extrusion dry applications. Probiotics do not need to colonize. They just need to deliver a health benefit. And in terms of the choosing the probiotic, do so in regard to the evidence, not necessarily by the number or CFUs that are delivered. More doesn't always necessarily indicate better. And I think in terms of that, I also encourage you to take a look at a recent publication utilizing this strain. That's in the Frontiers of Veterinary Science, February 6, 2025. And that's by Argavani et al. And it's really looking at the impact of Saccharomyces cerevisiae on the intestinal microbiota of dogs with antibiotic-induced dysbiosis. I think particularly in terms of these yeast, particularly for dogs and cats that have a high risk of receiving antibiotic use, these yeast are really good options to take a look at with regard to a probiotic delivery. So with that, I will thank you for Ashoff, and I will do my best to answer any questions that you may have.
Thank you so much. Is there any question from the audience or from the chat? Maybe you can bring the microphone here, Nadine. I think we have a question from the floor.
Yeah, thank you so much, Russell, for this inspiring presentation. So my question, you're talking your perspectives that you maybe test your strain in other disease model. What did you think? What about which disease you think about?
Yeah, so I think it's a good question. We haven't tested in any specific disease models, but I think those are great options for probiotic targets. And as I mentioned at the end, I think for yeast probiotics, they are really attractive options for dogs or cats that are at high risk for receiving an antibiotic, in terms as part of their normal health care. Whether that be, skin or GI related, if they are likely to receive an antibiotic, on an annual basis at least once, this may be the yeast probiotics may be great options.
Any other question? Yes, we have one question there.
Hi, Russ. It's Diane.
Hello.
I just wanted to ask, so is this the plan for this usage to be sprayed on dry food after extrusion, or is it planned more as a supplement use?
Yeah, I mean, it could be both. I mean, we develop it to be applied for dry food or dry treats, just from a stability standpoint, post extrusion or post baking. In terms of that, it's we do get a really nice profile with regard to shelf life, approaching 18 to 20 months after post application. But it could be used in a supplement as well.
Okay, there is another question there. One more. Many questions for you, Russell.
For Asha.
Thank you very much for your presentation. At the end, you mentioned that the more is not always the better. Is there any side effects of having either a very long complementation with that kind of probiotics or with a high concentration of them?
I think in terms of that, I think each study, I'm going to say suggests that we should evaluate in vivo the effect of these probiotics, because we know that they impact metabolism, whether that be from the I'm going to say other beneficial bacteria that are accompanying them in the GI tract, or their impact on potential pathogenic bacteria. In terms of that, we need to really assess, in terms of dosage, suggested dosage range. Make sure that we're providing an efficacious level, but make sure, B, make sure that we're not negatively influencing metabolic profiles by simply overwhelming the system. So it's not I'm going to say I don't have a set number that we shouldn't exceed. I think it's an individual strain standpoint.
Sorry. So you plan to use this strain both for dog and cats, or more specifically dog?
More at this point, we recommend for dog.
Okay.
Oh, one more question.
Two small questions. One is
Sure.
about yeast, because of course Saccharomyces are associated with food, and we can find them. I mean, we know most of them very well, but there is other type of yeast. So do you think it worth investigating a little bit the potential beneficial properties of other yeast? That's one question. And the second question is that there is, in the world of probiotics, there is a probiotic solution based only on one species or one strain, and other which are combination of species, strain. And so do you have any comment on that, or do you have a vision where we should favor single strain or mix of strain?
Yeah, so in terms of your first question, if I understood it correctly, is what are my feelings on I'm going to say in terms of other variants of yeast? Yeah, I think in terms of just like within bacteria, there are going to be numerous strains of yeast that can be demonstrated to be beneficial. It likely will not be every strain that's tested in terms of that, but I'm going to say we shouldn't anticipate that only one variant of yeast is going to deliver beneficial impact as a probiotic when delivered in terms of a live microorganism. With regard to combination single strains versus combinations, again, I think in terms of the single strain, we can almost assure that what benefits we monitor if we're using a single strain approach can be attributed to that strain. If we're utilizing combinations, it becomes a little bit more difficult to determine exactly which of the contributing microorganisms is driving what benefits. But I think from an overall approach, I think we have to, if we have a combination that scientifically has shown a benefit to the animal, we shouldn't discount it just because it's a combination. Certainly our overall goals are to improve and support the health of our companion animals. So I don't know if that answered your last question or not, but I don't know that there is a clear answer. It's just my opinion.
Hello, Russ. Very, very fast. Technical question. Is this approved in Europe? Can we use it in Europe or not?
It is not, at this point, it is not approved in Europe. And that was pointed out on the first slide that I couldn't see. But the Ashoff had pointed out that this product is not approved for Europe at this point.
Okay, thank you.
Okay, thank you very much, Russell. We can applaud Russell for this nice intervention.
Yeah,
Thanks
thank
to
you.